Hi, in this video we're going to solve paper 1 from May-June 2022 series. Let's have a look at the first question. Okay, so this question is about binomial expansion, and first of all I'm going to state the formula. A plus b to the power of n equals to the sum, where k goes from 0 to n, nck a to the power of n minus k times b to the power of k. Okay, how can I use it in this case? Now, n is going to be equal to 4, so we'll have the sum, k goes from 0 to 4, 4ck, p to the power of 4 minus k, and then x over p to the power of k. And we also know that the coefficient of x cubed in this expression is 144. So that means somewhere in this expansion we're going to have 144 x cubed. Now, I'm not going to expand the full thing. I will only find the coefficient that I'm looking for, which is the coefficient of x to the power of 3. Now, just by looking at this formula, we can see that we're interested in a case where k equals to 3, because that's how I can get x cubed from this expression. Okay, so substituting k equals to 3 into this formula will give us 4c3. Next, p to the power of 1 x cubed over p to the power of 3. Or it's going to be 4p times x cubed over p cubed. Simplify this a little bit and we get 4x cubed over p squared. Now the coefficient of x cubed is going to be 4 over p squared. And this should be equal to 144. So our equation for p is going to be 4 over p squared equals to 144. And now all we have to do is to solve this for p. P squared is going to be 4 over 144. Simplify this. That's going to be 2 over 72 or 1 over 36. Now take the square root. And don't forget to have two values, positive and negative. So p is plus or minus 1 over 6. And that's going to be my answer for the first question. Now time for the second one. That's about graph transformations. And to start with, let's have a look at the function y equals to sine theta without any p, q, and r's. Its graph is going to look like this. Theta, y, we start from 0, 0, and we go like that. And the key points are going to be pi over 2, pi, 3 pi over 2, and 2 pi. And sine theta is going to go from -1 to 1. Now, we can compare our graph of y equals to y equals p sine q theta plus r to the original graph of y equals to sine theta and see what the values of p, q, and r are. Okay, so let's start with the value of p. We know that normally sine goes from -1 to 1, so that means that the range of this function is 2. Now, what's the range of that function? It is from -5 to 1, so the range is 6. Okay, so it means the function got stretched 3 times on y axis. So that gives us the value of p as 3. Okay, let's move on to the next one. State the value of q. Now in that formula, q is going to affect stretch on the horizontal axis. Again, looking at sine theta, Let's choose 2 points on this graph, from maximum to minimum. Now the distance is going to be 3 pi over 2 minus pi over 2, which is pi. And now let's see what happened after the transformation. From 3 pi to pi, the distance is 2 pi. So it means the function got stretched 2 times on horizontal axis. And that means that q is 1 over 2. And it's very important not to get confused between stretch on x-axis and y-axis. If you are stretching with the scale factor of 2, for example, on y-axis, that means the number in front of sine x would be 2. But if you are stretching with the scale factor of 2 on the horizontal axis, that will be sine theta over 2, and not sine 2 theta. So that's a little bit counterintuitive. Okay, next one, state the value of r. Now, in this formula, r is responsible for the vertical movement. Again, let's compare the graph of sine theta to what we have in our picture. Now, the graph sine theta is oscillating around the line y equals to 0. Let me draw it on a graph. Now, where's the center of this graph? It's here. Y equals to minus 2. So that means the graph was translated down by 2 units. That gives us the value of r as negative 2. Let's move on to the next one. Next question is about arithmetic progression. And to start with, let's quickly summarize everything that we're given in the question. We know that the first term is 4. I will say a1 equals to 4. We have a common difference, d. And we know that the sum of the first n terms is 5863. Okay, and on top is what we have to show. Right, so first of all, I will start with the formula for the sum of the first n terms, which is the first term plus the last term, an, over 2 times the number of terms. Now, the nth formula for arithmetic progression is going to be the first term plus difference times n minus 1. And we know that the first term is going to be 4. So an equals to 4 plus d times n minus 1. Okay, now let's substitute everything into the formula for the nth term. And we'll get 4 plus 4 plus d n minus 1 divided by 2 times n, and that equals to 5863. Now we'll have to rearrange this equation and get what we are asked to get. 4 plus 4 is 8 plus d n minus 1 over 2 times n equals to 5863. Let's multiply both sides by 2, and we'll get 8 plus d n minus 1, everything times n, equals to 11726. That's divided by n, we'll get 8 plus d n minus 1, equals to 11726 over n. And now all I have to do is to move 8 from the right side to the left. So n minus 1 times d equals to 11726 over n minus 8. That's exactly what we had to show. Okay, next one, we know that the nth term is 139. We're looking for n, and we're looking for d. Alright, since we're given the nth term, let's start with the formula for the nth term, which is a1 we know it's 4, plus d times n minus 1, and that should be equal to 139. Now, from this equation, we can move 4 to the other side, and we'll get d times n minus 1 equals to 135. And I can use it to combine with the result from the first question, which is n minus 1 times d equals to 11,726 divided by n minus 8. And I will treat it as simultaneous equations. Okay, so from here, I can substitute 135 to the left side of the second equation, and I will get 135 equals to 11,726 over n minus 8. So that means 11,726 over n equals to 143. I can find n from here. And I get n equals to 82. Now we can use the fact that d times n minus 1 equals to 135. Let's substitute n in there. So we get d times 81 equals to 135. And from here we can find d, which is 135 over 81. Simplify that and we'll get 5 over 3. Let's take both values as the final answer. D equals to 5 over 3. N equals to 82. Next question is about graph transformations, and we have quadratic function, which is being translated by some vector. Now, it is important to realize that the function is not being stretched. It's only being translated. So what really changes is the coordinate of the vertex. And if we can find a new vertex of a translated function, we pretty much know everything we have to know. Okay, so to start with, let's find the vertex of the old function, x squared plus 2x minus 5. I'm going to complete the square. That would be x plus a half of a number in front of x, which is 1, squared. Take away the square of that number, so minus 1 and minus 5. So we got y equals to x plus 1 squared minus 6. Okay, and from here, we can equate the bracket to 0. X plus 1 equals to 0, so x equals to minus 1, and the y-coordinate of the vertex is here, it's minus 6. So the vertex is, let's call it point P, minus 1 and minus 6. Okay, what happens is that we have a vector minus 1 and 3, so the new vertex, Pn for the new one, is going to be minus 2, minus 3. Okay, and now I can write the equation of the quadratic function using the vertex. So it's going to be x plus 2 squared minus 3. Now we can expand the brackets. For x plus 4, take away 3 and get the final answer. Y equals to x squared plus 4x plus 1. Okay, let's have a look at the next one. Again, graph transformations. Right, and this time the curve is being stretched because the coefficient of x squared is changing and the coefficient of x is also changing. Okay, but we can notice that the new function, I will call it g of x, is the old one, y but only if you replace x with 2x. But that means our graph was stretched along x axis, and the stretch factor is 1/2. So that's basically what we have to write. It's stretch parallel to x-axis stretch factor is 1/2. Next, I have to solve the equation. To start with, I will say that the square root of y equals to t, so I'm making a variable change, so I get 6t plus 2 over t minus 7 equals to 0. I have to solve that, and I will multiply everything by the denominator, which is t, so I get 6t squared minus 7t plus 2 equals to 0. That's a simple quadratics. I'm just going to use the formula. T equals to 7 plus or minus 49 minus 4ac, which is 48, over 2a, so it's 12. If I take the plus sign in the formula, I will get 8 over 12. That simplifies to 2 over 3. And if I take the minus sign, I will get 6 over 12, or 1 over 2. Now, that's not the final answer yet, because that's just only t. So let's substitute back. Then we'll get square root of y equals to 1 over 2, or the second case, the square root of y equals to 2/3. Now square both, and we'll get the final answer. Answer. It's going to be 1 over 4, or 4 over 9. Okay, next one. Hence we solve the trigonometric equation. Okay, now we know that tangent x from the previous question equals to 1 over 4, or tangent x equals to 4 over 9. Okay, now what I have to do is to take the inverse tangent of both. For the first one, I'll get x equals to 14 degrees, or x equals to 194 degrees. For the second one, I will get x equals to 23.96. I'll just say it's 24. And then don't forget, you can add 180. And that will be 204. And all four values are going to go in the final answer for that question. So 14, 24, 194, and finally 204. Okay, next one. We'll have to complete the square. Let's just copy the question. 2x squared minus 16x plus 23. And we have a very standard technique for that. Whenever we have something in front of x squared, I take this something out of the bracket. So I'll get 2 times x squared minus 8x plus 23. And then I will complete the square inside those squared brackets. I can write it as x minus half of the number in front of x, which is 4, squared minus squared number in the brackets. So it's 16 plus 23. Now expand the square brackets by multiplying by 2, and we'll get 2 times x minus 4 squared minus 32 plus 23. Simplify that, and we'll get 2 times x minus 4 squared minus 9. And that's the answer. 2 times x minus 4 squared minus 9. Right, the next question is about the range of the function. And as always, I think the best way is to draw the sketch of that function. So let's a quadratic function, and we can clearly see the coordinate of the vertex. So that number outside of the bracket is the y coordinate. And to find the x coordinate of the vertex, all we have to do is to make the squared bracket equals to 0. So that gives us x equals to 4. So the vertex is 4 minus 9. Let's draw a very rough sketch. 4 minus 9 is somewhere here. Let's say it opens like that. Okay, and for now, the range of this function is y is bigger or equal than minus 9. However, let's have a look at the question. It says that x is smaller than 3. Now look at the graph. X equals to 3 is here, and the y coordinate, which corresponds to x equals to 3, is right there. So the range of the function is going to be y is bigger than that value that corresponds to x equals to 3. Now, all we have to do is to find that value. Basically, I'm looking for y of 3. Okay, substitute it and get 2 times 3 minus 4 squared minus 9. That is minus 7. So that means our range y is bigger than minus 7. Let's have a look at the next one. Find an expression for the inverse function. We have a very standard procedure for that, which is a two-step technique. The first one, swap x and y. And the second step is going to be make y the subject of the formula. So get x equals to 2 times y minus 4 squared minus 9. And then make y the subject. So what I'm going to do is to move minus 9 to the left side with a plus sign. So it's x plus 9 equals to 2 times y minus 4 squared. Divide everything by 2. So get x plus 9 divided by 2 equals to y minus 4 squared. Now I will take the square root of both sides. And when I do it, I will get two values, positive and negative. That gives me y minus 4. Then I will have to rearrange it and get minus 4 on the other side. That will be y equals to 4 plus or minus square root of x plus 9 over 2. But we're not done yet. We have to figure out whether it's plus or minus. Let's have a look at the domain of the original function. They tell us that x is less than 3. Now, let's choose some value of x which is less than 3. I would say x equals to 0. And then I'm going to substitute it into the original function. So y of 0, that equals to, that is 23. Now, what that means? It means that the inverse function of 23 must be 0. And that's my key of finding out whether I should take plus or minus. Now, without any calculations, look at the formula for the inverse. It's 4 plus or minus the square root of x plus 9 over 2. So basically I start with 4 and I should get 0. That means I will have to take minus. However, let's check it out and see if it's true or not. So the inverse of 23 equals to 4. I'm going to choose minus. Okay, 23 plus 9 over 2. And if you do the calculations, it clearly gives you 0. So that's exactly what it should be. Okay, let's state the final answer. The inverse equals to 4 minus square root of x plus 9 over 2. Let's have a look at the next one. Okay, this question is about composite functions. We're looking for f of g of x. And we have to read the composition from right to left. So that means g goes into f. So first, just to make it a bit easier to understand, let's replace x with g in f. So it's going to look like this: 2 times g minus 4 squared minus 9. And now what is g? G equals to 2x plus 4. So let's substitute this in our expression, and we'll get 2 times 2x plus 4 minus 4 squared minus 9. Simplify that. 4 minus 4 is 0. So get 2 times 2x squared minus 9, which is 2 times 4x squared minus 9, or 8x squared. Take away 9. That's the answer. F of g of x equals to 8x squared minus 9. Okay. Okay, next one is about the equation of the circle, which is right here. X minus a squared plus y minus b squared equals to r squared. And in this equation, the point C with coordinates a and b is the center of the circle, and r is the radius. If you look at this equation, yeah, you can spot the center straight away. The center is going to be 2 and minus 4, and we know the point B. So that means we can find the equation of the line BC quite easily. Let me just copy those points. B is 0, 2. C is 2 minus 4. And the equation of the line looks like y equals to mx plus c, where m is the gradient. Let's find the gradient first. It's going to be difference in y over difference in x, which in that case would be 2 minus 4 over 0 minus 2. Minus and minus will be plus, so I get 6 divided by minus 2, which is negative 3. And c is the y-intercept, and we don't really have to do anything in this case because we can see it straight away, right? The line intersects y-axis at a point 0, 2, so 2 is our y-intercept. And we're ready to state the answer. Y equals to minus 3x plus 2. Let's have a look at the next one. Hence find the coordinates of P. And P is the intersection of the circle and the line. Now, whenever you have to find intersection, that probably means you'll have to solve simultaneous equations. So let's write it down. Equation of the circle is this one. And the equation of the line from the previous part is minus 3x plus 2. Okay, I'm going to substitute the second equation, minus 3x plus 2, into the first one, and I will get x minus 2 squared plus minus 3x, 4 plus 2 is going to be 6, squared equals to 20. Now, I will just rearrange the second bracket a little bit. Instead of minus 3x plus 6, I will say it's 6 minus 3x, just because it is more convenient to work with. Now, to expand the brackets, I'm going to use the formula a minus b squared equals to a squared minus 2ab plus b squared. Okay, the first bracket becomes x squared minus 4x plus 4, and the second one is 36 minus 2 times 6 is 12 times 3. It's going to be minus 36x plus 9x squared. Now we'll move 20 from the right side to the left straight away just to save some time. Now let's put everything together. X squared plus 9x squared is going to be 10x squared. Okay, and oh, I forgot x next to minus 36. So altogether that's minus 40x, and then for just a number, it's going to be plus 20 equals to 0, quadratics. But first, I will divide it by 10 to make the numbers a bit smaller. Plus 2 equals to 0, and I will use the formula. Or plus or minus square root of b squared is 16 minus 4ac, which is 8 divided by 2. Simplify that. Now, don't forget, the question says find in the exact form, so we don't need a decimal. I will think of 8 as 4 times 2. Okay, and then the square root of 4 becomes 2. And then square root of 2 over 2. Okay, divide by 2. I'll get x equals to 2 plus or minus square root of 2. Okay, now the question is, should we take plus or minus, or should we take both? Let's have a look at the graph. We're looking for coordinates of P, and then the point P is to the left of the center. And the x-coordinate of the center is 2, so if we want to have something on the left of 2, we should take the negative sign. So x is actually equals to 2 minus square root of 2. And now we can find the y-coordinate of the intersection by substituting 2 minus square root of 2 into any of the equations, and I will go with the second one, y equals to minus 3x plus 2, just because it's way much easier. Minus 3 times 2 minus square root of 2 plus 2. And if I expand the brackets, I will get minus 6 plus 3 square root of 2 plus 2. So y equals to minus 4 plus 3 square root of 2. Okay, now we got both x and y, and let's state this as the final answer. 2 minus square root of 2 and minus 4 plus 3 square root of 2. Right, the next question is about the tangent to the curve at point A. Now, the equation of this line is going to be, as always, y equals to mx plus c. Now, first of all, let's start with the gradient of a tangent, which is also known as the derivative of the curve at a certain point. So, first of all, let's find the derivative of the curve. It's going to be 1 over 2 x to the power of minus a half, right? I'm subtracting 1 from the power, minus 4 times 1 over 2, that is 2, x to the power of negative 3 over 2. Now, the point we're looking at is A, so I'm going to substitute the x-coordinate of this point, which is 1, so y derivative of 1 equals to 1 over 2 minus 2, that becomes minus 3 over 2. And we know that our tangent line looks like y equals to minus 3 over 2x plus c. Now, our goal is to find out the value of c. How to do this? As we can see from the graph, the tangent and the curve share the same point when they intersect. So that means if x equals to 1, then the y-coordinate of the curve should be equal to the y-coordinate of a tangent, which is 5. So y of 1 must be 5. Okay, so let's substitute 1, 5 into the equation of the tangent, and we'll get 5 equals to minus 3 over 2 plus c. Rearrange for c, and we'll get c equals to 5 plus 3 over 2, which is 6.5. Okay, looks like we're done with the tangent. So y equals minus, instead of 3 over 2, I'm going to write 1.5 x plus 6.5. That's the answer. calculate the area of the shaded region. Okay, and to do so, we can do it in two ways. The first one would be the integral of the upper curve, or in this case, it's a straight line. Then we'll have to take away the lower, then take the integral of that dx. So it's one way, but I think in that case, the easiest method would be to find the area of the rectangle, and then take away the area under the curve, which is going to be given by the integral from 1 to 16. So that's my plan. First, I'm going to start with the integral from 1 to 16 of the curve, which is x to the power of 1 over 2 plus 4x to the power of minus 1 over 2 dx. Integrate. That gives me 2 times x to the power of 3 over 2 over 3 plus 4. Increase the power of x by 1, so it's a half, divided by 1 over 2, which is the same as timesing by 2 over 1. And all of that is from 1 to 16. Now I'm going to substitute the upper limit, and I will get 42 and 2/3 plus 32. That's when x equals to 16, and then take away 2/3 plus 8. That's when x equals to 1. So all in all, that gives us 66. Now that's the area under the curve. Okay, now we have to find the area of the rectangle. Let's have a look at it. So the height of the rectangle is 5, and the length would be 15. 15 and 5, so the area would be 75. Okay, now we can do 75 minus 66. And we'll get the area we're looking for. That will be 9. And that's the answer for that question. Answer 9. Okay, next question. Find the perimeter of the shaded region. Let's have a look at the picture. So we already know that BC is 6. That's good. Now we need the arc length, which is going to be r times theta. And we also need the length BD, which is the radius of the sector. Radius minus 6. Okay, so technically all we have to know is the radius and the angle. By the way, that's angle theta. Okay, so first of all, let's maybe start with the radius. We can use the cosine rule in a triangle ABC to find AC. So AC squared is going to be 6 squared plus another 6 squared minus 2 times 6 times 6 times cosine 1.8. When we calculate that, that's going to be 88.358. Then take the square root. Then we get AC, also known as radius, equals to 9.4. Okay, so now we know the radius. Let's find the angle of the sector, again using the triangle. We know that all angles add up to 180 degrees, or pi radians. So the angle is going to be pi minus 1.8, then divided by 2. Okay, now we know everything to find the perimeter. So radius minus 6, that's going to be 3.4. Now radius times theta is going to be 6.305. Now all we have to do is to add everything up. It's going to be 6 plus 6.305 plus 3.4. And that is 15.7. And that's the answer. Okay, next question. Find the area of the shaded region. Let's have a look at the picture. And we can see that the area of the shaded region would be the area of a sector minus the area of the triangle ABC. Now we have formulas for that. Area of a sector is going to be r squared times theta over 2, so it's the sector, minus the area of a triangle would be a half AB sine C, minus the triangle. Now in this formula, when we calculate the area of a sector, then angle theta is going to be pi minus 1.8 divided by 2. And when we calculate the area of a triangle, A and B are going to be 6 and 6, and angle C should be the angle in between those sides, which is 1.8. So now we can substitute all of this in the formula and get the answer. So the radius was already found in question A, so 9.4 squared times angle theta, which is 0.6708 divided by 2, minus, now the triangle, a half times 6 times another 6 times sine of the angle in between, which is 1.8 radians. And if we calculate all of that, then we get the answer 12.11. And that's pretty much it. Answer 12.11. And let's have a look at the next one. Calculate the integral. Okay, let's write it down. The integral from 1 to infinity of 4x plus 2 to the power of minus 2 dx. That's going to be 4x plus 2. Now increase the power by 1, I will get minus 1, divided by the new power, it's minus 1. Then don't forget to times by 4, which is the number in front of x. And we have to evaluate this from 1 to infinity. First of all, let's write it as a fraction, and we'll get minus 1 over 4. Then 4x plus 2 will go to the bottom of the fraction, we'll get 4x plus 2 in the denominator, from 1 to infinity. Now first let's substitute the upper limit, which is infinity, and try to think what happens if you put a really large number at the bottom of the fraction. The result is going to be really small, and if the number is infinity, then you actually get 0. Then take away what we get when we substitute the lower limit, which is 1. Let's substitute that. We get 1 over 4 times 6. 4 times 6 is 24. Minus and minus will give us a plus. So all in all, we get 1 over 24, which is the answer. Okay, next question is about the rate of change. We have the function y equals f of x, and I've already copied it here from the question. And there is some point A at which the y-coordinate is decreasing at the rate of k units per second. So that means dy over dt is going to be minus, because decreasing, k. Now we also know that the x-coordinate is increasing, so that means derivative is positive. Dy over dt equals to positive k. And now we have to find the coordinates of A. Oh, sorry, that's supposed to be dx over dt. Now we have dy over dt and we have dx over dt. What we can get from here is dy over dx. And all I have to do is to take dy over dt. And to get dy over dx, I can multiply by dx by dt over dx. Now we know that dy over dt is minus k. And we know that dx over dt is k, so if I flip it over, I get dt over dx, which is 1 over k. So all in all, we get minus 1. So what we know from here is that dy over dx equals to minus 1. And that's going to be our key equation to find point A. Now we know that the derivative with respect to x is minus 1, and we know the equation of the function. So from here, let's find dy over dx and then equate it to minus 1, and hopefully we can solve it. Okay, so dy over dx is going to be minus 2 times 4x plus 2 to the power of minus 3, and then using the chain rule, I will have to multiply all of this by derivative of the inside, which is 4. If I simplify that, I will get minus 8 over 4x plus 2 cubed. And now we can write the equation. Minus 8 over 4x plus 2 cubed equals to minus 1. Let's times everything by minus 1. We get plus and plus. Now times by the denominator, we get 8 equals to 4x plus 2 cubed. Take a cube root, and we get 2 equals to 4x plus 2, or that gives us x equals to 0. Okay, so now we have the x-coordinate of the point A, and all we have to do is to substitute this x-coordinate into y. And we'll get y equals to 2 to the power of minus 2, which is 1 over 2 to the power of positive 2, or 1 over 4. Okay, these are two coordinates of the point A. So the answer is 0, 1 over 4. Okay, question 11, that's 6 marks. Let's have a careful look at this one. So we have a curve, y equals to minus m over x, and let's say it looks similar to this. Y equals to minus m over x, and m is a positive constant, and there's also the line y equals to mx plus c, and then at some point p, and there's only one such point, the line is tangent to the curve. So it looks like that. Y equals to mx plus c, and we have to find the coordinates of this point. Okay, let's analyze what happens at the point P. Well, the curve and the line share this point, so that means we can substitute x and y coordinates to both of the equations. And also, because the line is tangent to the curve, that means the gradient of the curve equals to the gradient of the straight line. And as we know, the gradient of the curve is given by the derivative. So the derivative must be equal to the gradient of the line, which is m. Okay, now let's find the derivative of the curve. We know that y equals to minus m and x to the power of minus 1. That's differentiated, and we get minus times minus 1 times m x to the power of minus 2. So minus and minus will be plus, and we get m over x squared. Now that must be equal to m. So we get m over x squared equals to m. Divide both sides by m, and we get 1 over x squared equals to 1. Okay, now that's the equation we have to solve to find the x-coordinate of the point P. Let's multiply both sides by x squared, and we get x squared equals to 1. And from here, x must be equal to plus or minus 1. Now the big question is it plus or is it minus 1? Now remember, because the curve and the line share point P, that means their x-coordinates are equal and their y-coordinates are equal. So that means, let's say x equals to positive 1. That means the y-coordinates must be the same, and we get mx plus c equals to minus m over x. I'm going to substitute x equals to 1, and we get m plus c equals to minus m. Okay, have a look at the question one more time. They tell us that m and c are positive constants. Now, m is bigger than 0. C is also bigger than 0. So m plus c must be bigger than 0. M is also positive, so it's bigger than 0. And if you multiply by minus 1, you get something smaller than 0. Now that's a contradiction, because on the left side we have a positive number, and then on the right side we have a negative number. That cannot be true. So that means x should be equal to minus 1. And now all we have to do is to substitute x equals to minus 1 into the equation of the curve. So y equals to minus m over x, and we get y equals to minus m over minus 1, minus and minus gives us a plus, so we get y equals to m. So all in all, the point P has coordinates minus 1 and positive m. Okay, and the question says, find the coordinates of P given the y coordinate in terms of m. That's exactly what we got. Alright, and the very last question of this paper. It's normal to the curve at P intersects the curve again at the point Q. Find the coordinates of Q in terms of m. Okay, fine. Let's draw a very rough sketch of what's going on in this question. So we have a curve, and I know it's not really minus m over x, but that's just a sketch to analyze what's happening. Now we have a point P on this curve. We have a tangent line. Okay, and we've got the normal, which goes at 90 degrees. Then it's going to intersect the curve again at some point Q. And Q is what we are looking for. Okay, to start with, we already know coordinates of P in terms of m. So P is going to be minus 1 and m. And also we know how to find the gradient of the normal from equation of the tangent. Because if two lines are perpendicular, then the gradient of the second line is going to be minus 1 over the gradient of the first line. So that means the gradient of the normal equals to minus 1 over the gradient of the tangent. So that means we can write down the equation of the tangent as y equals to minus 1 over m, because that's the gradient of the tangent, x, and then plus c, and I'm going to emphasize that is cn as c of the normal. Okay, now, what happens at the point of the intersection? The y-coordinates of the curve must be equal to the y-coordinate of the normal. Okay, so that means we've got the curve minus m over x, and then equation of the normal is going to be minus 1 over m x plus cn, and they must be equal. Okay, now we know that the curve and the normal share the point P. So that means I can substitute x equals to minus 1 into this equation. And that's probably going to help me to figure out the value of Cn. So substitute x equals to minus 1, and I will get m equals to 1 over m plus c normal. So that means Cn equals to m minus 1 over m. Okay, and I can rewrite the equation of the normal as y equals to minus 1 over m x plus m minus 1 over m. That's c of the normal. Okay, when they intersect, again they share the same point. This time it's q. So we can say that 1 over m x plus m minus 1 over m, that's the normal, and it must be equal to the curve, which is minus m over x. And from this equation we can find the x-coordinate of the intersection. Okay, so first of all I'm going to get rid of the fractions. I will multiply both sides by the common denominator of the two fractions, which is mx, and I will get minus x squared plus m squared x minus x equals to minus m squared. Now for the next step, I'm going to rearrange everything and collect all the terms on the left side. So minus x squared plus m squared x minus x plus m squared equals to 0. Now that is obviously quadratics, and let me multiply by minus 1 first. Okay, and then we can factorize x out. So we'll get x squared plus bracket, let's do 1 minus m, x minus m squared equals to 0. Okay, now from that equation, a equals to 1, b equals to 1 minus m, and then c equals to minus m squared. And I'm going to use the quadratic formula to find the value of x. So x is going to be, okay, minus b, which is, oh, forgot the square. Minus b is going to be m squared minus 1 plus or minus square root of b squared, 1 minus m squared again, minus 4 is c. C is negative, so all in all we get a plus 4m squared divided by 2a. A is 1, so I just got 2. Okay, now we'll have to, oops, run out of space. Okay, let's simplify the expression under the square root. Let me just go here. M squared minus 1 plus or minus, open the brackets, 1 minus 2m squared plus m to the power 4 plus 4m squared, and all of this divided by 2. Okay, that simplifies to m squared minus 1 plus or minus. Okay, that's going to be m to the power 4 plus 2m squared plus 1 over 2. And we can see that under the square root we have a complete square. And when I take the square root, it's going to be m squared plus 1 over 2. Now, in this formula, when I take the plus sign, I will get m squared. And if I take the minus sign, that simplifies to minus 1. Now, which one is the x-coordinate of the point Q? We know that point P has the x-coordinate of minus 1. So that is point P. That means the point Q has the x-coordinate of m squared. Now, all we have to do is to find the y-coordinate of that point. So y equals to, we can substitute it into minus m over x, which is minus m over m squared. And I got minus 1 over m. And we get the final answer. So x equals to m squared. And y equals to minus 1 over m. And that's the final question of this paper. I hope you find it useful. I will see you next time. Bye.